Today we're going to solve a problem that is perhaps the easiest, simplest, most intuitive, just ridiculously trivial medium Leetcode problem in the history of all the Leetcode problems that at least I've solved. Okay. So let's go ahead and get right into it. It shouldn't take even more than 5 minutes. So 1637, widest vertical area between 2 points containing no points. Okay. You're given n points on a 2D plane where points I equals xi, yi. Okay. So you're given the x position and the y position, right? If you've taken, algebra or any math class where you graph, that idea makes sense, right? X, y. Return the widest vertical area between 2 points such that there are no points inside the area. A vertical area is an area of fixed width extending infinitely along the y-axis. So it has infinite height. The widest vertical area is the one with the maximum width. Okay, so we only care about the width between areas. We don't care about the vertical area because we just consider it an infinite space. Okay. Note that the points on the edge of a vertical area are not considered included in that area. Okay, so in this problem, you just graph the points. So we have 8, 7. So 6, 7, 8, 4, 5, 6, 7. So that's this point. 9, 9, 9, 9. That's this point. 7, 4. That's 7, 4. That's this point. 9, 7. That's 9, 7. That's this point. Okay. Now, again, we don't care about the distances, these horizontal distances, just the vertical widths, right? So we can't do an infinite one here. It has to be in between two things, right? So it doesn't count like an infinite width from here all the way to the left, right? Because there's nothing on the other side to catch it, right? There has to be points in between. So there's a width one vertical, what do you call it again? Vertical area here and another width 1 here, right? So the answer is 1. And if we did 3, 1, 9, 0, 1, 0, 1, 4, 5, 3, 8, 8. I guess the first thing to think about here is, well, what's weird is the y positions don't matter, right? The fact that this is width 1 because there's a point at 8 and a point at 9. The location of them on the horizontal axis, or their location horizontally, is irrelevant, right? The fact that this point is here, or if this point was here, or here, or here, or here, or here, it does not matter. The only thing that matters is the position, the x position, right? Where is it on this line vertically, right? We don't care about where it is here. It doesn't change anything, right? If this was here, it's the same. If it's all the way up here, it's the same. It doesn't matter. Okay. So the first thing you can kind of do here is we'll say, okay, we can just disregard these values that determine where they are vertically, right? 8, 7, right? What only matters is the x position, right? So 8, 9, 7, 9. And what I did there is I took the 8, I took the 9, I took the 7, and I took the 9, right? And I just disregarded the y position because it doesn't matter where they are, right? So that's why it's kind of funny, there's some sort of kind of irrelevant aspect to this problem that you're given. Same with, let's do the other problem though instead, but just note that, I don't need to graph this out because, these y positions don't change anything because we're just thinking about it with respect to the vertical distance. Okay, so I'm going to redraw out these points. So it's 3, 9, 1, 1, 5, 8, right? 3, 9, 1, 1, 5, 8. All right, again, we don't care about these y positions. And, well, we're trying to find the maximum width. Right, so you might feel inclined to say, okay, we have 3 then 9, so the maximum width is 6, right? But that doesn't work because there can't be things in between, right? Any point between 3 and 9 could cut off, and it won't actually be from 3 to 9. It would only be from 3 to 9 if there was 3 and then there was 9. So the best way to ensure that you're getting points that are by each other with nothing in between is to sort this system, right? If I sort this system and I call it 1, 1, 3, 5, 8, 9, well, now I know that from this 1 and to this 3, there's nothing in between. Because if there was something in between, it would be within the array when I sort it. Right? So if I sort the system first, I get a better idea of, okay, then there's this, then there's this, then there's this, then there's this. Right? Because what I'll really do is I'll just go to each edge. I'll go to each point and say, okay, in between this point and the next point, right, what's that area? Between this next point and the next point, what's that area? And so on and so forth. Right? So all I really need to do is I need to take points, and I'm going to sort it in place. I'm going to imagine this is an in-place sorting algorithm. Of course, you can use an in-place heap sort or something. And all I need to do is sort it based on the x position, right? So that's position 0. And then I just need to return the maximum distance, right? Because what I'm going to do is I'm going to look at each individual point, right? So I'm going to say points of I minus points of I minus 1. And I just have to look at the x position. right? Because this will give me each point, and 0 will give me the x position of that point. And I look at all the points in the range from 1 to the length of points. So basically what I'm doing is I'm sorting the system, and that will let me easily traverse through and just say, okay, from this point to the next point, what's the area? And I know since it's sorted, there's no points in between. Okay, from this point to the next point, what's the area? So on and so forth. Okay, so let's say n is the length of points. Maybe I should submit this before. All right, let's say time is, well, we have to sort the array, right? So that's going to be in place heap sort. So that's O n log n. And then for space, well, let's just say that this is an in place sort. It might not actually be, right? It could be n log n if, it takes n log n space to sort, or n space or whatever. But let's just say for the sake of this that it's constant, okay? Because you can sort using heap sort. If this was in place heap sort, we'll just say for the sake of argument that it is. And if it's not, then whatever. Okay, guys, hope you have a beautiful rest of your day. That's all it is for this problem today. Boom.